Alright, hello everyone, welcome back. I'm your friend in Saxo. Let's continue to learn our mathematics. I think this is probably the second important materials that you need to learn, because as I think the mathematics now becomes a fundamental of, or it's always a fundamental of software engineer or computing science, because you probably do not have to be a master of mathematics to be a software engineer, but you have to at least understand those basic concepts or those keywords about the mathematics, For example, the decimals. If you do not know this kind of concept, you would probably wouldn't know the float type in a programming language. So anyway, let's get started.
So I have a number written here. It's a 2, a 3, and a 5. And we already have some experience with numbers like this. We can think about what does it represent. And to think about that, we just have to look at the actual place value. So this rightmost place right over here, this is the ones place. So this 5 represents 5 ones, or I guess you could say that's just going to be 5. This 3, this is in the tens place. This is in the tens place. So we have 3 tens. So that's just going to be 30. And the 2 is in the hundreds place. So putting a 2 there means that we have 200. So this number we can view as 235. Or you could view it as 200 plus 30 plus 5. Now what I want to do in this video is think about place values to the right of the ones place. And you might say, wait, I always thought that the ones place was the place furthest to the right. Well, everything that we've done so far, it has been. But to show that you can go even further to the right, I'm going to put a little dot. I'm going to put a little dot right over here, and we call that a decimal point. And that dot means that anything to the right of this is going to be place values that are smaller, I guess you could say, than the ones place. So right to the left, you have the ones place and the tens place and the hundreds place. And if you were to keep going, you'd go to the thousands place and the 10,000s place. But then if you go to the right of the decimal point, now you're going to divide by 10. So what am I talking about? Well, right to the right of the decimal point, you are going to have, find a new color, this is going to be the tenths place. This is going to be the tenths place. Well, what does that mean? Well, if whatever number I write here, that tells us how many tenths we're dealing with. So if I were to write the number, 4 right over here, now my number is 200s plus 3 tens plus 5 ones plus 4 tenths. So you could view this as 4 times 1/10, or you could write this as 4 tenths, not tens, 4 tenths, or 4 tenths is the same thing as this right over here. So this is a super important idea in mathematics. I can now use our place values to represent fractions. So this right over here, this 0.4, this is 4 tenths. So another way to write this number, I could write it this way. I could write it as 230, let me do the 30 in blue, 230, 235, and 4 tenths. So I could write it like this as a mixed number. So this up here would be a decimal representation, 235.4, and this right over here would be a mixed number representation, 235 and 4 tenths, but they all represent 200 plus 30 plus 5 plus 4 tenths. Let's look at a few more examples. So let's say I were to write the number. 0.7, and actually let me go one space even further to the right. 0.76. So what would this be if I were to write it as a fraction? So let's just think about the place value. We have our decimal point. To the left of the decimal point is the ones place. But I have a 0 there, so this is 0, 1. Now I have 7 tenths, so this is the tenths place. And then this is going to be this place to the right of that. We're going to divide by 10 again. So this is going to be the hundredths place. Right? This base right over here is going to be the hundredths place. So this number right over here is, we can rewrite it as 0. We could rewrite it as 0 ones plus 7 tenths plus 7 tenths, not tens, tenths, plus 6 hundredths, not hundreds, hundredths. Or we could write this as 0 plus 7 tenths. Write that a little bit neater. Plus 7 tenths plus 600 plus 6 hundredths. 6 over 100. So you could write this 7 tenths plus 6 hundredths is exactly what this is. You could say this is 0 ones, 7 tenths, and 6 hundredths. Now, another way we could write this, you might be tempted, well, look, if we wanted to write it as a fraction or talk about it as a fraction, I could ignore the 0. That's not going to change the value of this sum. But I could add the 7/10 to the 6/100. So how could I write 7/10 in terms of hundredths? Well, 7 over 10 is the same thing as 70 over 100. 7/10 is the same thing as 70 over 100. One way to think about it is if I have 10 times, if I multiply the denominator by 10, well, I can multiply the numerator by 10 as well and not change the value of it. 7/10 is the same thing as 70/100, and then you could add 6/100 to that, 6/100 to that, and what will that give you? Well, that's going to give you 76/100. 76/100. So this number up here, a lot of people will call this, they might say 0.76, or they might call this 76 hundredths. 76 hundredths. This is the hundredths place. This is the tenths place. But each tenth is worth 10 hundredths. And you see that. This is you could either view this as 7/10ths, or you could view it as 70 hundredths. So this is 76 hundredths. And you could keep going to the right. If you go to the right one more space, you would get to the thousandths place, and then the 10,000ths place. So you keep dividing by 10 each place you go to the right, and you multiply by 10 each place you go to the left.
Okay, so you understand the concept of decimal. It's basically just a number with a dot inside of it. It's a float number if you know program already. Okay, here's another, I guess, important idea. Rounding decimals, because sometimes the numbers after the dot symbol could be very long. So in this case, you might want to get rid of some of those numbers. Okay, let's have an idea of how can we do such a thing.
Round 9.54 or 9 564 thousandths to the nearest tenth. So let me write it a little bit larger. 9.564. And we need to round to the nearest tenth. So what's the tenth place? Tenth place is right here. This right here represents 5/10. This is the ones place. This is the tenths place, the hundredths place, and this is the thousandths place right here. So we need to round the nearest tenth. If we round up, this will be 9.6. If we round down, this will be 9.5. And just like regular rounding, when we're not dealing with decimals, you move to one spot, or you look at one place to the right, or one place lower, I guess, and you say, is that 5 or larger? Is, you round up. Isn't, you round down. 6 is definitely 5 or larger, so we want to round up. We want to round up. So this 9.564 becomes 9.6, or we could call this 9 6/10. Then we're done.
Okay, that's basically the idea of decimal rounding. As for the comparing decimal, I guess you probably do not have to know the details about it because, let's say the Python would handle it. So, for example, if now we got our Python variable, let's say if 1.5 or 1.6 greater than 1.2, the answer would be true. But whether 0.6 less than 0.5, the answer would be false. Okay, so you don't have to know that kind of low level of concept. Rewriting decimals as fractions. Okay, let's just look at a simple example
Let's
here.
write 0.8 as a fraction. So 0.8, the 8 right over here is in the tenths place. It is the tenths place. So you could read this as 8/10. And we can write that literally as being equal to 8/10, or 8 over 10. And now we've already written it as a fraction, and if we want, we can simplify this down. Both 8 and 10 share common factors. They're both divisible by 2. So let's divide both the numerator and the denominator by 2. We're not changing the value of the fraction because we're dividing by both the numerator and the denominator by the same thing. 8 divided by 2 is 4. 10 divided by 2 is 5. And we're done. 0.8 is the same thing as 8/10, which is the same thing as 4/5.
Okay, that's quite, simple and easy for us to understand. As for the adding, I guess you still do not have to know the details about that because Python handle it for you. How about multiplying decimals? This is kind of important for you to understand because sometimes you have to do it by yourself.
52 times 706 is equal to 39,624. Then we're told to match expression to its product. And these products, size on Khan Academy, you can move them around so the product can be matched to the appropriate expression. Pause this video and see if you can figure that out. All right. Now, what you might have realized is all of these expressions deal with the same digits as 52 times 702. They just have the decimal in different places. So what we can do is we can say, hey, look, the answer is going to have the digits 394 in that order. And you could see all of these have the digits 39624 in that order. And then we can estimate what these expressions equal to, what the product should be equal to think about the decimal. So this first expression, 0.52 times 70.2, the way I think about it is 0.52 close to 50/100, close to a half. And so 76.2, that's close to 76. And so this first expression, this first product, should be roughly half of 76. Half of 76 be around 38. So which of these is close to 38? Well, this first one is 39.624. So that's closest to 38. The second one is 396. And then we have 3,962. So I like this first one, 39.4. That feels right. Now, the second expression is 0.52 times 762. Well, once again, 0.52 is roughly hundredths, roughly equal to 5/10, roughly equal to 1/2. So, and 762, we could say, hey, you know, that's, if we want to be really rough, really approximate it, say, hey, it's roughly 800. So this should be about half of 800. So it should be around 400. And so we actually had that choice already there. So this would be 394. It definitely wouldn't be the 3009.4. So I'm already feeling good that this last choice sits down here. But I can verify it. 5.2. Well, let's just say that's roughly 5. 762, let's say that's roughly 800. 5 times 800, that would be around, that would be 4,000. So we would expect this expression to be close to 4,000, and indeed, that's what choice is. So it turns out that it was already in the order that we needed.
All right. Doesn't have that much meaning as I think it would. So I guess those, let's say, operations like dividing, multiplying, adding, subtracting, they are working just exactly like what you do with whole numbers, with integers. So we shouldn't care about that too much. Let's go back a little bit. Okay, then if that's the case, we are done for today's learning, for today's mathematics learning, because that's how the decimal works and the whole idea about decimal. Okay, I'll see you guys in the next one. Bye.